Is evolution predictable? There are many cases in nature where natural selection has favored the evolution of similar structures. From beak shapes in birds, to color patterns in fish, to wing pattern mimicry in butterflies. I work on a group of neotropical butterflies called Heliconius that have bright colors that warn predators of their toxicity. We know that predators quickly learn to associate these patterns with a bad experience. Think about how you and I avoid picking up a wasp or hornet because we recognize black and yellow as painful.
Ouch.
Heliconius use their patterns to warn predators that they are toxic, and different species of Heliconius have evolved the same appearance. Evolution favors mimics, but does evolution use the same recipe to arrive at the same outcome? In other words, do butterflies use the same strategies to develop identical wing patterns? About 12 million years ago, Heliconius formed, and very early split into two groups that evolved separately, creating a great diversity of wing patterns, but also often converging on the same costume, so that two distantly related species may look identical. We studied 3 of those pairs of mimetic butterflies, each found together in large overlapping regions across Central America. In this study, we wanted to understand how pairs of mimics end up with the same wing patterns. We decided to focus on a specific gene in Heliconius called Wnt that gives the instructions for the shapes and boundaries of colors on the wings. We used a powerful new technology called CRISPR to remove the gene and asked how did the pattern change. CRISPR works by injecting butterfly embryos with an enzyme coupled to a guide molecule that targets and disables the Wnt gene. What we found was fascinating. For each member of a pair, removing Wnt generated different results. Both butterflies are using Wnt to color and pattern their wings, but they're using it in very different ways. We were so intrigued by this result that we wondered how broadly does this gene affect pattern variation. So, we extended our research and removed this gene from a total of 12 different species and 10 subspecies of Heliconius. Again, we saw a fantastic range of effects, confirming the fundamental role this gene plays in generating wing pattern. What these results tell us is very interesting. 2 unrelated butterflies may develop the same wing pattern, but the pathway to that outcome is different. And our results suggest that different paths they use involve modifying the way Wnt is expressed in the wing and how it interacts with other genes that create shape and color. The bottom line is that, to some extent, evolution is not predictable. Even across relatively short time periods, genetic variation allows organisms to explore different ways of solving a common problem. And this has important implications for the way we understand life on Earth.